Good morning, students. Welcome to my channel. Today's we are going to discuss about central force, that is unit 3 chapter central forces. So what is a central force means if the force on a body which is always towards a fixed point, it is called a central force. Take the fixed point as the origin. So a force on a body always towards a fixed point. Examples of central forces: uniform circular motion, force due to gravitation, simple harmonic motion, projectile motion, uniformly accelerated motion, others like electrostatic, magnetostatic forces. These are the examples of central forces. So, properties of central force. Central force field is conservative, means constant, there is no change. Central force field is a conservative force, that is equals to constant. Angular momentum is conserved, that is L is equals to constant. Motion is a planar straight line. So examples: gravitational force, electrostatic field, spring force. So gravitational force, two planet revolving around the planet, so it is a in the line, so this is because of central force. So next, another important topic: conservative force as a negative gradient of potential energy. Here conservative force, just now we discussed, conservative means constant force. If force is represented symbolically as F, so F is negative gradient of potential energy. A potential energy denoted by U. So gradient, we know, that is represented like this. So F is equals to force as a negative gradient like gradient of potential energy. Here potential energy denoted by U. So F is equals to minus grad U. So here F force is a vector quantity. Here force is a vector quantity. U is potential energy, that is scalar quantity. Here F is a vector quantity, potential energy is a scalar quantity. So to balance this equation, we have to utilize grade here. To balance this equation, we have to utilize grade here, that is grade also expressed as del. F is equals to minus del U. We need to prove this. So when a particle acted upon, when a particle acted up on by a conservative force, F moves from a space point x naught, y naught, z naught to another space, point x, y, z. Then potential energy at R is given by, then P means potential energy at R is given by U of R, potential energy of distance R, displacement, integration F dot dr. This is equation 1 from 0 to r. So here negative sign indicates a particle away from the origin. Here negative sign indicates a particle away from the origin. E of r potential energy is equal to minus f dot dr 0 to r. Here negative sign indicates a particle away from the origin. So in this, the total energy of the system we have to integrate. Now express f and dr rectangular coordinates. So I cap fx plus j cap fy plus k cap fz. This is considered as equation A for understanding purpose. Dr also position vectors represented as I cap dx plus j cap dy plus k cap dz. So here dr is the distance moved by the particle. Here dr is the distance moved by the particle. So multiplying f dot dr is equals to f dot dr is equals to so this one into this one. I cap fx plus j cap fy plus k cap fz. I cap dx plus j cap dy plus k cap dz. So here I dot I j dot j k dot k r is equals to 1. I dot I j dot j k dot k is equals to 1. So I dot j or j dot k or k dot I they are equals to 0. Only I dot I j dot j k dot k are equals to 1 in vector product formulas. So here I dot I j dot j k dot k terms మాత్రమే మిగులుతాయి, మిగతా అన్ని క్యాన్సిల్ 0 అయిపోతాయి. సో f dot dr is equals to I dot I టర్మ్ మాత్రమే మిగులుతుంది అంటే fx dx. నెక్స్ట్ j డాట్ j టర్మ్ మాత్రమే మిగులుతుంది అంటే fy dy. నెక్స్ట్ k డాట్ k టర్మ్ మాత్రమే మిగులుతుంది fz dz. సో fx dx ప్లస్ fy dy ప్లస్ fz dz. This is equation 2. So substitute equation 2 in equation 1. So equation 2 is f dot dr. This is equation 2. So in this place f dot dr in this place were replaced by this equation. So put equation 2 in equation 1. So we have to get substitute equation 2 in equation 1. We have to get u of r is equals to minus x naught to x. I take individual xyz components, y naught to y, fy dy, z naught to z, fz dz. So here u of r xyz, r is xyz components, x naught to x, fx dx, y naught to y, fy dy, z naught to z, fz dz. Now differentiate equation. This is equation 3. Now differentiate equation 3 partially with respect to xyz. Partial differentiate equation 3 with x with respect to x, y, z components. We get so f of x with respect to x, this is minus dou u by dou x. Fy we get minus dou u by dou y. Fz similarly minus dou u by dou z. So partial differentiate equation 3 along xyz. Here x component dou u by dou x, dou u by dou y, dou u by dou z we get. Next put the values. So here fx, fy, fz, put these values in fx, fy, fz values ఈక్వేషన్లో సబ్స్టిట్యూట్ అంటే fx ప్లేస్లో మైనస్ డో యూ బై డో ఎక్స్, fy ప్లేస్లో మైనస్ డో యూ బై డో వై, fz ప్లేస్లో మైనస్ డో యూ బై డో జెడ్ ఉంటుంది. సో దోస్ ఆర్ సబ్స్టిట్యూట్ ఇన్ ఈక్వేషన్ ఏ. Now put above values in equation A. Equation A లో ఈ వాల్యూ సబ్స్టిట్యూట్ చేస్తున్నాం. Now we get సో ఆ ఈక్వేషన్ ఏంటో మళ్ళీ రాసుకుంటున్నాం ఇక్కడ. fx, fy, fz kk from A. This is equation 1. So in this equation we substitute those below values. We get f is equals to I cap dou u by dou x minus j cap dou u by dou y minus k cap dou u by dou z. So common minus here. So I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. A common minus here. So you commonly write it as like this. So here f is equals to minus I into dou by dou x plus j cap dou by dou y plus k cap dou by dou z. We already known the value, so that is del. So this is del u. This is F is equals to minus del u. For conservative force is a negative gradient of potential energy. So here force is a vector quantity, potential energy is a scalar quantity. To balance this equation we utilize grad, that is del. F is equals to minus del u.